Hello everyone, in this video I explain how to determine the refractive index of a piece of glass by using Snell's law. Let us start. First of all, what will happen to the ray when it passes from two different mediums? For example, from air into glass. So, from air into glass, they are two different mediums of two different densities. So the speed of light will be changes. As it enters from less density medium, from air to glass, glass is more dense than air, so the ray it will be bent toward the normal. So this is the incident ray, and this is the normal line. So the ray it will be bent toward the normal. As the ray passes from the glass into air, it will be bent away to the normal because the speed of light increases. What about Snell's law? Snell's law talks about that. This is the angle of incidence and this is the angle of refraction. So sine angle of incidence divided by sine angle of refraction equals a constant called the refractive index. This refractive index of the second medium with respect to the first medium. We have another form of Snell's law. That one is N1 sine theta 1 equals N2 sine theta 2. The refractive index of glass is about 1.5. And the refractive index of air approximately equals 1, and the refractive index of diamond is 2.4. Now let us start the practice. The apparatus that we need: paper, foam, piece of glass, pens, protractor, ruler, and pencil. Let us start. So first we put white paper on the foam at the middle, fix it. At the middle of that white paper, place the piece of glass. And now around the edge we draw rectangle. So around the edge, take care and be careful. Remove the glass away, and approximately after 1 centimeter from the edge, draw perpendicular line. This is called the normal line. So this is perpendicular line. Then start to measure angle of incidence equals 30 degrees. So we draw angle 0, 10, 20, 30. So this angle now it becomes angle of incidence. Then put two pens, one and then little far we put another one. That are the two pens. Place the glass again at its position and then look through the glass with one eye. So what we do, we look through the glass with one eye. So press a pen and another one. Remember, you have to look with one eye through the glass. So the four pens must be on the same line through the glass. Now that exactly the four pens. If you look up, it will be not on the same line, but through the glass with one eye, they will be on the same line. Now what we do, remove the glass away and then connect the points of that other two pens. Also draw the normal to the other side. Remove this one. Now we have this figure. So we have this figure. It is rectangle. Now what we do now to check our method, is it correct or no? This angle is angle of incidence and this angle is angle of refraction in air. If our working is perfect, the angle of refraction in air denoted by theta R dash equal the angle of incidence in air. So we measure this angle. It is exactly 30 degrees. So it's perfect. Now what we do, we draw that 2 points inside the rectangle. This angle is the angle of refraction. We measure this angle. So this angle is 18 degrees. So this is the first try. Theta I, it is 30 degrees. Theta R, it's 18 degrees. Theta R dash, it is 30 degrees. What is N? It is the refractive index. It is sine theta I over sine theta R. So N, it is sine 30 divided by sine 18. So we use the calculator with degree mode to get this one. So it's 1.6. This is the first try. Now we repeat another try. So we remove that paper and replace it by another paper, and we repeat the same job. Now we repeat our job with another angle 40 degrees. So we measure angle 40 degrees to be angle of incidence. 0, 10, 20, 30, 40 degrees. This angle now is 40 degrees. 2 pins, one and the other on the same line. Place the glass again in its position. Be careful and look through the glass. So we look through the glass with one eye. So we put one pin and another. The 4 pins inside the glass must be on the same line. Now we remove the glass, join that 2 points, draw, measure the angle of refraction in air. Okay, it's also 40 degrees, so it's perfect. Now measure the 2 points inside the rectangle to measure the angle of refraction. So we measure this angle. So this angle is 25. Now the second trial. Okay. Theta I is 40. Theta R is 25 degrees. Theta R dash it's 40. We calculate N in the second case, in the second trial. So it is sine 40 divided by sine 25, 1.5. We repeat the job, the third trial. The third angle is 50 degrees. So the angle of incidence, in this case, it will be 50 degrees. 0, 10, 20, 30, 40, 50 degrees, exactly. So the third trial, when the angle of incidence is 50, the angle of refraction is 30 degrees, and the 3R that, the angle of refraction in air, it is 50 degrees. Now we find N in the third case. So sine 50 divided by sine 30, it is 1.5 also. So what we do now, we take the average of the 3 readings. The average is 1.53. Now we answer the questions here. When the light passes from air from air to glass, does it refract toward the normal or away from it toward the normal? Why the line refract toward the normal? Because the speed of light decreases as it passes from air to glass, because the glass is more dense than the air. Because the speed of light decreases as it passes from less denser medium to more denser medium, as from air to glass. Glass is denser medium. Compare the calculated value of N to the actual value of index of refraction of glass. The refraction index of glass is about 1.5. Our value is a little bit more, so we say 1.53 divided by 1.5. So the answer is 1.02. Our calculated value is 1.02 times more than the actual value of refractive index of glass. What are the sources of error in this experiment? Okay, parallax error for measuring the angle or seeing the bends inside the glass. What will happen to the angle of refraction, theta r, if the glass is replaced by diamond? Diamond is more dense than the glass, so the refractive index of glass, it will be less. So what will happen to the angle of refraction, theta r, in the glass? If the glass is diamond, theta r, it will be decreases, less than in glass. So in diamond, theta r to be less than in glass. Why? Because diamond is denser than glass. What about the conclusion? Why we did this experiment? To determine the refractive index of glass. In our experiment, we made 3 trials. In the first trial, we found that refractive index is 1.6. In the second and third was 1.5, and the average, it's about 1.53, approximately the same as the refractive index of glass, 1.5. So we used Snell's law to calculate the refractive index of glass. I hope you understand this experiment. Thank you.